Hello everyone, here we have the example for the topic differentiation. Use the first principle to find the derivative of gx, which is square root of x minus 1. So given the formula on the right hand side, we have the formula for the first principle. So kindly substitute the situation. So limit when h approaching 0, g bracket x plus h. So meaning we will have square root of x plus h minus 1. Kindly substitute the x plus h into x. Then minus square root of x minus 1 over h. So now kindly substitute the value 0 and we will obtain square root of x minus 1 minus square root of x minus 1 over 0. So as we all know, square root of x minus 1 minus square root of x minus 1 will obtain 0. So the situation will be what we call the indeterminate form. So there are three strategies that we can use to solve this kind of situation. Number 1, multiply by the conjugate. Number 2, factorize the situation. Number 3, long division. So for this question, my suggestion would be multiply with the conjugate. So now kindly focus on the conjugate. So we need to multiply with the conjugate, and the conjugate will be x plus h minus 1 plus square root of x minus 1 over square root of x plus h minus 1 plus square root of x minus 1. So kindly expand the situation, and please take note, only expand for the numerator. So rewrite the situation. Limit when h approaching 0. If we expand this part, and we will obtain x plus h minus 1, followed by multiply this part, and we will obtain plus square root of x plus h minus 1 multiply with x minus 1 square root. Next, focus on this part, and we will have minus square root of x minus 1 multiply with square root of x plus h minus 1. Next, kindly expand the situation, and we will have negative bracket x minus 1 over h bracket square root of x plus h minus 1 plus square root of x minus 1. Kindly focus on the numerator, simplify the situation. So we can simplify the situation, become 0. Next, x minus x will obtain 0. Negative 1 plus 1. So finally, rewrite the situation. Limits when h approaching 0, we will have h over h multiply with square root of x plus h minus 1 plus square root of x minus 1. Simplify the situation, and finally we will have limit when h approaching 0, 1 over square root of x plus h minus 1 plus square root of x minus 1. If we substitute the situation, and we will obtain 1 over square root of x minus 1 plus square root of x minus 1. So finally, we will have f prime x is equals to 1 over 2 multiply with square root of x minus 1. So kindly focus on the question B. Given that exponent y plus xy plus ln bracket 1 plus 2x is equals to 1, where the x must be greater than equals to 0. Show that the situation given. Hence, find the value of the second derivative at the point 0, 0. So we have two parts. Let's focus on the part 1, show the situation. So given the situation, exponent y plus xy plus ln bracket 1 plus 2x is equals to 1. Kindly differentiate the situation with respect to x. Kindly differentiate the situation with respect to x. So if we differentiate exponent y and we will obtain exponent y. Kindly focus on the power. If we differentiate and we will have dy dx plus we have xy. So we need to use the product rule. Kindly differentiate the situation where we have y multiplied with 1 plus x. Differentiate the y and we will have dy dx plus differentiate ln and we will have 1 over 1 plus 2x. Kindly focus on the internal part, differentiate the situation and we will obtain 2 equals to 0. Exponent y prime plus y plus x y prime plus 2 bracket 1 plus 2x to the power of negative 1 equals to 0. Kindly differentiate the situation for the second time with respect to x. So, given the situation where we have y prime, differentiate exponent y and we will obtain exponent y. Focus on the power, differentiate and we will have y prime plus exponent y. Kindly differentiate y prime and we will obtain y double prime. Next, focus on y. Differentiate y and we will have y prime. Next, focus on x multiplied with y prime. So plus y prime bracket multiply with 1 plus x. Differentiate the y prime and we will obtain y double prime plus 2. Differentiate this part and we will obtain negative 1 bracket 1 plus 2x to the power of negative 2. Do remember to differentiate the internal function and we have 2 equals to 0. Rewrite the situation. So we will have exponent y bracket y prime square plus exponent y double prime plus y prime plus y prime plus x multiplied with y double prime. Rewrite the situation for this part and we will have negative 4 over 1 plus 2x to the power of 2, which is equals to 0. Simplify the situation, so we will have exponent y plus x bracket second derivative then focus on this part. Rewrite the situation. and we will have plus exponent y bracket first derivative square. Next, add on the situation. So we will have plus 2 dy dx minus 4 over 1 plus 2x square equals to 0. So kindly refers to the situation, and we have shown the situation. So now we are going to focus on the second part, meaning that we are going to find the value of the second derivative at the point 0, 0. So given the information, we have x and y is equals to 0. So now kindly substitute into the first equation in order to find the value of dy dx. So if we substitute the situation, and we will have exponent 0 dy dx plus 0 plus 0 multiply with dy dx plus 2 over 1 plus 0 equals to 0. Rewrite the situation. So we will have dy dx plus 2 equals to 0. So meaning that our first derivative or the gradient will be equals to negative 2. Then substitute the value dy dx equals to negative 2, x equals to 0, y is equals to 0 into the second equation in order to find the value for the second derivative. So rewrite the situation. So e to the power of 0 plus 0 bracket, we have the second derivative plus e0, where we have the first derivative negative 2 square plus 2 multiplied with negative 2 minus 4 over 1 plus 0 square. So simplify the situation. In this part where we have 1 plus 0, so we will have second derivative. In here we will have 1 multiplied with 4. Next we have negative 4 minus with negative 4 equals to 0. So we can simplify the situation. So finally, the value for the second derivative will be equals to 4 when the dy dx is equals to negative 2, x is equals to 0, and y is equals to 0. So now the value for the second derivative is equals to 4 at the point 0, 0. So here we are, and thanks for watching.